The gravity of the time is such that every new avenue of peace, no matter how dimly discernible, should be explored. Never before in history has so much hope for so many people been gathered together in a single organization. You will provide a great share of the wisdom, of the courage, and the faith which can bring to this world lasting peace for all nations and happiness and well-being for all men.
Today we have with us on Titans of Nuclear, Brett with two T's, as I like to call him. Brett Rampal, welcome to the show.
Thanks, Brett. Thanks for having me. So yeah. Brett Alpha, Brett Beta. No, I'm just kidding.
Yeah, which one is which is the real question.
Exactly.
So I know Brett personally. You've been a good friend of mine since the beginning of this nuclear journey. I want to thank you up front for all the insights that you've shared with me, for your straightforward, candid attitude. I think you're one of a kind in the industry. Right now, you're serving as the Director of Nuclear Innovation at the Clean Air Task Force, but I'd like to go through your whole nuclear history. So Brett, start us off.
Yeah, sure. Absolutely. And first of all, thanks so much for having me. A pleasure to be included in, this auspicious group of interviews and everything that you've been doing over the last couple of years. It's been my pleasure to also, support your journey and participate and all that. So, thank you for the kind words. So like you said, I'm Brett Rampal. I'm the current Director of Nuclear Innovation for Clean Air Task Force. I've served in this role. I've served in a role at Clean Air Task Force for a little over 3 years now. My sort of nuclear journey really began in my collegiate career at the University of Florida. I entered my undergraduate at UF in 2003.
In nuclear? Was your undergrad in nuclear?
Yeah, I always knew I wanted to do engineering of some kind. And I really, had very few preconceived notions going into it. I was a very strong math and science student at, in high school, had all these AP class, all this stuff, but didn't really know anything about engineering. My dad's a gynecologist. My mom was a retired nurse. I showed up for preview orientation. They throw all these, thousands of kids through auditoriums all day at this giant university, and trying to give you, a blast of what each college is all about and everything. And I remember sitting there with my older brother and my mother, and my older brother was already an undergraduate at Florida, and the dean of the College of Engineering at that time came up and said we had 2 top 10 engineering schools at the University of Florida right now. One is materials engineering and one is nuclear engineering. And I looked at my older brother and I looked at him and I'm like, "You're materials engineering, right?" And he's like, "Yeah." And I was like, strike number 1 against materials engineering. And then I opened up the book and showed you the classes, and it showed you that you needed like 6 semesters or 7 semesters of chemistry for nuclear or for materials engineering, but you only needed like 2 semesters of chemistry, and it was a lot more physics and math for nuclear engineering. And so I was like, strike number 2. And I elbowed my mom and I was like, "We can leave now. Let's leave. Let's go."
I got this.
Yeah, and we literally walked out of the union in the auditorium where they do this on campus. And the nuclear engineering building is like directly out the back of Florida's Union in almost in like the center of like the old traditional campus. And then it's like a stone's throw from Ben Hill Griffin Stadium, the football stadium. You literally walk across the street. And the materials engineering building is right there too, but it's further back. So a little bit further away from the stadium. And I was like, strike number 3, it's closer to football. And so that's how I picked my major in nuclear engineering. So as a young sophomore, 19-year-old kid, knowing nothing about nuclear engineering, I started my first classes And, my first class within, 15, 20 minutes, one of my professors, the late, great Edward Dugan, Dr. Ed Dugan, um, dispelled every myth and, explained everything about, nuclear science that, we embraced, that I embraced in my career, and, low, clean energy, high density, nuclear power plants can't blow up like a bomb. I was a very, very, you know, um, misinformed person going into those classes. And I sat in that first class, and I'm a person that believed in math and science and physics. And in 20 minutes, I was like, wow, what have I learned all my life?
It's amazing because it really does only take 20 minutes if you are, let's say, like math inclined, to dispel all of those myths that people have about nuclear. But that's what also makes it so hard, because how do you get 20 minutes of everyone in the world's like day to correct some of these misconceptions?
And there's, not to say anything, math inclination is not, universal
Yeah,
also,
that's a very polite way to put it, Brett. Yes.
yeah, math and physics, embracing that is not
Yeah.
something that a lot of people, embrace either at an early age or, even later into their life. We still are in a society that pushes for, more science-based understanding and everything. So yeah, I mean, what worked for me certainly wouldn't work for everybody, but that was my sort of, toes into the pool of nuclear engineering. And it certainly wasn't um, um, a obstacle list or a smooth track for me as a young sophomore in nuclear engineering classes, where I shouldn't be. You're supposed, at Florida, I came in with all these credits from my AP classes. You're supposed to start in your junior classes at nuclear engineering. I actually failed some of my first, nuclear engineering classes because I was just so young and wasn't prepared for it. And I had come from a high school experience that was great in, one of the number one Florida public high schools, but I hadn't ever really been challenged like that. It was, I like to say it to a lot of the younger nuclear engineering students or people considering nuclear engineering when they ask me for advice and stuff. And I say, nuclear engineering is hard.
Yeah.
And there's a reason for that. Reactor physics is hard. Nuclear physics is hard. All of this stuff is hard. So you gotta work at it. And I learned that early on, thankfully. But it was not a smooth or easy experience. So I spent 6 years at Florida. I got my bachelor's and master's in nuclear engineering and nuclear engineering sciences. While I was getting my master's, I started an internship with eventually turned into a co-op ship sort of contract relationship with General Electric Hitachi and Global Nuclear Fuels, their fuel alliance subsidiary with Hitachi and Toshiba at the time. And I spent little over a year, probably total combined over the experiences, working over the course of 2 years, working for GE as I finished my master's, and was lucky enough to be throwing a American Nuclear Society student conference at Florida in 2009, my last year as a graduate student.
Right. And I want to double click on that for a second, because you were one of the things I've noticed about you is that you're just like very engaged, like community wise. I mean, I know you do the sports thing. You're a big like Gator guy also. Gator's the right team.
Yeah, you got it.
Okay.
So yeah, I like to say I'm a very foolish person and that doesn't know how to say no, but is very generous with my time.
And to ANS too, right? Because you've done a lot of leadership. Oh, sorry. ANS is the American Nuclear Society, correct?
Absolutely, yeah. So that's like the traditional professional society and association for nuclear engineers or nuclear professionals or people, in the nuclear field. It's, certainly open to more than that. But for me as a young student as a student in college, it was very well conveyed to us that participation in sort of the extracurricular, professional societies, volunteer opportunities that you feel, strongly about. That sort of stuff can be useful in making a stronger network in your career, and can also be a differentiator if you're ever trying to, compete for jobs. And as a young nuclear engineer, I was very concerned about, competition for jobs, especially back in 2009 when, this nuclear renaissance was beginning. I as a student got involved in the American Nuclear Society. I eventually went on to lead their young members group and participate on numerous different committees and technical divisions. I currently sit on their public policy and external affairs committee. So yeah, I like to say that almost everything I've given to the American Nuclear Society, in a lot of ways I've gotten back. I feel the network, the connection, in a lot of ways I feel like I met people like you through,
Actually, I think that's the first time, I think even before like we met, I'd seen you speak at an I guess there's American Youth Nuclear Society or something. There's one of these like youth events or something, conferences or something. And you were up there, you were on the stage and you were talking to everybody about something or other. And I was like, that's a guy that can talk.
So probably Young Professionals Congress.
Young Professionals, yeah.
An event that the Young Members Group at ANS throws every 2 years to get, a real focus on young members and young nuclear engineers and young nuclear professionals. So yeah, those were things that I was I am and was super passionate about. I unfortunately turned 36 on May, in May of this year. So I officially will no longer be a young member in a short time.
Hey, but you could be president now, right?
Yeah, maybe one day, so there's a rotation for ANS president in order to make it well considered, and in order to really have the president not really be from one sort of facet of the industry and everything. So I think it's like an industry lab, they vendor sort of cycle that they do there. And I think I just missed mine. So it'll be, a few more years before they, that would be a possibility. But sure, maybe, but
I was talking about President of the United States, by the way.
You're
right,
way more
Brett. Think small, why don't you? Yeah,
way more ambitious than me, but you are correct. I am now constitutionally qualified, born in America, and will be over 35. So yeah. I guess I should form a pact, right? That's the next step. No, I'm kidding. Yeah. So, and then in addition to ANS, I ran a chapter of my alumni association here in Charlotte, North Carolina, where I live for 7 or 8 years. Really helped, made strong connections, at my back at my university, made strong connections locally in my town.
And Charlotte's got a nuclear tradition, right? Is it EPRI that's out there?
Well, there's EPRI, Duke Energy's headquarters are here, which is, I think still at this point, the largest public utility in the United States, and also has a large, set of nuclear assets. So yeah, I mean, University of Florida is in Gainesville, Florida. And as I was mentioning, I was in my, graduate year in 2009, I was helping with this student conference through ANS at Florida. And I was very lucky enough through that process to get exposed to, a bunch of different sponsor organizations and companies, and help set up job fairs and career fairs, and was able to pass, my resume around. And that introduced me to the Westinghouse Electric Company. And so after I got my master's and my contract ended at General Electric Hitachi, I started in July of 2009 with Westinghouse. And originally I moved to Pittsburgh, Pennsylvania, which is where Westinghouse is headquartered, for 6 to 7 months of training. But then my role was always to help them start up and participate in one of their first remote satellite offices that they were trying to open close to their customers here in Charlotte, North Carolina. Like I said, nuclear renaissance, Duke Energy was considering building multiple AP1000s during that time. And so lots of opportunities for Westinghouse, young nuclear engineers. And so it was a great pairing. That's how I ended up in Charlotte, where, I knew no one and had no connections previously. But to me, it seemed like a great opportunity and a move, because as a young nuclear engineer, looking at the geography of the United States and kind of where nuclear opportunities are, it might seem daunting that, hey, if I'm not 100% committed to my first job, or I don't see myself doing this for the next 40 years of my career, wherever I'm moving right now might be somewhat temporary, because I might have to move someplace else for another job. Because, like I said, when I first moved to Pittsburgh for training, there weren't necessarily a lot of competitive nuclear opportunities in Pittsburgh. But Charlotte was a little bit different. Westinghouse was opening this office here. Duke Energy has their offices here. Progress Energy, which eventually merged with Duke, had offices here. Arriva, or excuse me, it's now Framatome. Apologies to our friend.
To the French, yeah.
Apologies to our friends. Yeah, but Framatome had offices here. EPRI has a large location here. So Charlotte seemed, in a lot of ways, like, and I'm from Florida originally. I'm a Southern guy. Charlotte and
Southern guy with a New York attitude. Let's be clear.
Yeah, well, my mom's from Brooklyn, Charlotte seemed like a great opportunity and a bastion of sort of, nuclear opportunities or nuclear industry in sort of the South. I mean, that's changed a lot in 10 years. There's more opportunities elsewhere geography, but Charlotte is still a really strong sort of nuclear town, lots of opportunities here. And that's what brought me here, as in addition to the Westinghouse opportunity. And I spent 6 years at Westinghouse as in their nuclear fuel product line, doing core and, in core engineering, doing core design and reactor physics, and eventually then engineering, project management, and planning for Dominion's nuclear power plants that Westinghouse Electric supported.
Can we double click on that for a second too? Yeah. Can you tell me what's involved in reactor physics and core design for people who don't know, and then what's involved in the project management side?
Sure. So nuclear reactors are wonderful, fantastic things that are strongly regulated. And so as a part of that, essentially every time a plant shuts down for standard refueling, maintenance outage that they plan for, and they plan to reload or shuffle fuel and put in their new fuel, that essentially is treated pretty much in a lot of ways like a brand new reactor.
Wow.
And so
that's every 2 years.
Well, it depends on your reactor. The majority of the pressurized water reactors, that's the Westinghouse products that I worked on, were 18 months. Some work up to 24 months. So it's usually between 18 and 24 months. PWRs make up the majority of reactors in this country, and Westinghouse, while I worked there, provided the majority of the fuel to PWRs. And so as a part of a fuel contract, a customer who operates a nuclear reactor might request certain services from Westinghouse in order to support the licensing efforts that are required every time you shut down a reactor. It's called the 10 CFR 5059, the 5059, part 50.59 evaluation. So every time the plant shuts down, the plant has to do a whole bunch of analysis, this takes place well in advance of the shutdown, but we do it over the 18-month sort of cycle. They have to do all of these sort of reactor physics related analyses, in addition to thermal hydraulic analyses, chemistry analyses, transient analyses, all sorts of different analyses, either to validate or to supplement original reference analyses that were done in the plant's original final safety analysis report or original licensing basis or all that sort of stuff. And in that process, we also sort of create and validate the limits and the operational window that the plant will operate in the next 18 months. So we say, this is how these are the analysis that we need to do to, that are the limiting sort of concerning sort of parameters and accidents that can happen. These are the limits we assume in these analyses. If you stay within these windows and these limits, your plant is assured to operate safely. Submit your documentation to the NRC, get a stamp, and let's shut her down and start her up.
And what are the I guess the levers that you have to pull, the dials that you have to pull? It's essentially you're looking at temperatures, pressures, and then the fuel itself. The fuel are these series of fuel assemblies, 100 plus or whatever, that sit in some sort of geometric square lattice pattern, and each assembly you get to choose the enrichment and then like which slot it goes in. Essentially, are those the basic parameters?
Yeah, so basically how it really starts is you're usually starting with the development of a loading pattern. So you'll get their core, you get a picture of what their core looked like from the last cycle. My main plant, Millstone 3, and I was very lucky because I had a team at Dominion that also did a lot of this work. So it was like double redundancy validation. That's that's a lot more common nowadays, but it was less common back in the day. Westinghouse did a lot of work internally, and some customers didn't have, sort of the, their internal sort of support. But now, even a lot more customers are doing all the work internally. So what we'll get is we'll sit down with the customer in what you call a design initialization meeting. This is sort of the Westinghouse process. Other companies and vendors may call things differently, but effectively it's the same. You sit down with your customer, you figure out and you talk to them about sort of what their energy requirements are, how long they need to run the plant for, how much fuel they want to buy, any sort of concerns they've seen trending over the last couple of cycles, how things have traditionally operated the plant. You go through this whole questionnaire and checklist to be like, how is this? How is this? Are you planning in a change in this equipment? Are you planning a change in that equipment? How many fuel assemblies are you planning on buying this cycle? And then once we get all that information, we can then turn a core designer like myself, at the time loose, to kind of take all that information and assess how that translates into what the new core will look like. So that might be, well, they want to buy a new burnable poison, or they want to do, they want to, do one less assembly this cycle, or they want to do, they want to do any number of things different. They're replacing their control rods. They're doing something, and so core designers take all of that into account and spend, some can spend, depending on the difficulty of the task or, their skill. Some people are really fantastic at this and been doing it for decades. And some people have unique tools that they've created or unique tools that the customer allows them to use doing this design because they purchased those tools. And you'll spend time shuffling a core, on a computer program. You'll move the fuel around. You'll do a series of spot checks to see, what sort of parameters, where they're at, how, the power is peaking in certain assemblies, where it's getting hot, where it's not getting hot.
You're running simulations, essentially projecting how the core will perform over the next, 12 to 24 months.
Well, yeah. And essentially, once you get someplace where you think you're good, you'll start doing some more in-depth analyses, or what we would traditionally call a loading pattern risk assessment, check and gauge the the loading pattern, which is what you call, how you're going to load all the fuel and move everything, gauge the risk of, grid to rod fretting, which is a damage that can happen within fuel assemblies due to changes in thermodynamic or thermochemical properties within water and within the fuel, or where
there's like where there's like turbulence and rubbing. Is that
lots of, yeah, exactly, grid to rod, yeah, or where you could have crud develop, and crud, it can induce certain phenomenons in reactors, which are called things like sips and silk. Crud induced power shifts or crud induced localized corrosion, which can cause either damage to your fuel or shift where the power is being produced and just be problematic. So you want to gauge some of these different concerns quickly before you do the full-blown sort of reload safety analysis sort of checklist work that we would then subsequently be doing. You do this risk assessment. Once you're happy and the team is happy, you submit it to the customer. Maybe the customer's not happy. Maybe you iterate back and forth. You try to resolve certain things. You might have to do some rework, do some other stuff, but eventually you get to a point where everybody's okay with the level of risk for this loading pattern. It looks like it's going to pass through the safety analysis that we need to perform. And essentially now at that point, an engineering project manager, like what I was at the end of my time at Westinghouse, would step in and take the lead core designer, which would be the person who was doing all of this work at this time for this plant, and try to build a team. It would probably usually be the same sort of reactor physicists or core designers that have experience working on this plant. And this team of 5 or 6 individuals over the next month or 2 or 3 would do, steam line break analysis, reactor reactivity coefficient analyses, rod insertion accident analyses, rod drops, all this other stuff, document all these analyses, combine it all together in this reload safety evaluation checklist that says, you've passed, you've passed, you've passed, you've passed, you've passed. These are the new limits for this cycle. This is all good. Or you didn't pass. This is what we've done in order to resolve this, failure, what's going on here. And now we're, sending you this reload safety analysis checklist. You can, and a reload safety evaluation associated with it. And you, plant operator, can reference this in your 5059 evaluation that you submit to the NRC. And then that will happen several months before they will shut down. And then while the plant is doing their sort of 5059 work, which I, as a lead core designer or an EPM, may or may not be supporting, depending on the plant's needs, further supporting beyond what we've already done, my team may move into what we would call the operations phase, where we would be producing what is most commonly called a nuclear design report, which is essentially a Bible for the plant operators to say, hey, these are the curves of operation that I should see if I move my rods this way. I should see this sort of reactivity insertion. These are my windows for certain operational maneuvers. This is the predictions for what I should see, the measurements on my boards at certain times.
And is there a series of tests that happen when the reactor is on to validate this? So after you deliver this Bible, do then the first 3 months of operation, do you do a couple maneuvers of the control rods and see if it matches, if the performance matches up with your predictions?
3 months, you can't even start up the reactor until you do that. Okay, so what we call it startup physics testing. Okay. And for some customers and some plants at Westinghouse and at other vendors, we may be providing a startup physics testing report. And essentially there are certain sort of measurements that the plant will perform while they're doing these startup procedures. And these need to be validated by the predictions that we've performed using our codes and using, the assumptions and all the, all the stuff in the questionnaires and everything that we've done. And when those fall within review criteria, acceptance or review criteria, you're good to go, and you can submit documentation and say, our predictions are accurate for these reasons, we can start up our reactor. But if your predictions fall outside of the acceptance and review criteria, you might need to take additional action. And so there's startup physics testing standards. I believe it's ANSI 19.6.2. Look at this, pulling it out. Yeah. And essentially a plant will reference these standards, which have already been endorsed by the Nuclear Regulatory Commission, and say, these are my review and acceptance criteria, and these are the things I need to check, or I'm going to check, and these are the procedures, dynamic Rodworth measurements, subcritical Rodworth measurements, all this other stuff. And these are my criteria, and here we go. We have validated everything. NRC, please give us the approval to start up our reactor and start generating electrons.
Amazing. So, I mean, clearly you've built up a, quite a foundation of knowledge when it comes to the performance of reactor cores across, BWRs at GE when you were, I guess still in school, Westinghouse, where you got your a lot of, real life experience with plants. You were at a startup at some point. How many total years after your master's did you spend in the business of understanding reactor cores?
So my time at GE was during my master's.
During your master's, got it.
Yeah, so including my time at GE, about 12, no, less than, no, yeah, about 12 years, 11, 12 years.
Amazing.
Working at vendors. As you said, I after I left Westinghouse in September of 2014, and I joined NuScale as a fuel engineer there, and I stayed at NuScale until 2017, and that's when I joined Clean Air Task Force.
Amazing. Okay, so now you're switching gears. You've gone from having this real world experience, understanding how actual power plants run, how reactors are designed, and now getting into the policy world. What does Clean Air Task Force do, and why did they bring you aboard?
Yeah, so Clean Air Task Force is this 2021, we're celebrating our 25th anniversary.
Wow.
In October. Yeah, October.
I didn't realize people cared about clean air for that long.
Yeah, I mean, some of the stories my bosses will tell, or some of the people that have been at this company for 20 years or longer, even 15 or 10 years, are just crazy. So Clean Air Task Force is an environmental organization, think tank, law firm, subject matter expert group. We wear a lot of different hats, and we do a lot of different things. And Clean Air Task Force is really focused on helping, or seeing the world achieve these deep decarbonization goals that nations and utilities and states are making commitments for. But originally, the organization began, just as it's described, as an organization focused on clean air standards, clean air concerns. There's a great story I heard when I first started up here about one of the first things CATF did, Clean Air Task Force CATF did, was to buy emissions meters and to give them to school children riding on school buses to measure the emissions that they're getting from the back of the diesel buses on the buses every day. And that led to a lot of reform in the way emissions and are controlled from public school buses.
Yeah.
So, and even now today, I know that we're doing something similar in Europe and in the United States with really special high-powered thermal imaging cameras where some of my colleagues and some of our, CATF, folks are going out to pipelines or power plants and filming leaks or emissions where there are supposed to be no leaks and emissions. So yeah, I mean, so that, Clean Air Task Force covers a gamut of areas and technologies. We have multiple different focus areas from, super hot rock geothermal, methane, carbon capture and sequestration, super pollutants, decarbonized fossil fuels. And one of the focus areas we have is advanced nuclear energy systems and nuclear energy systems and advanced nuclear energy. I joined CATF, luckily enough, through the association at the Young Professionals Congress. Dr. Ashley Finan, who had my role prior to me, was a panelist on a panel I was throwing for that Congress I was helping run in 2017. And in orientation and conversation about the panel, she became aware that I was looking for new opportunities, and we talked about it. And she was looking for somebody to join the team, which was mostly just her at the time. And I, was very happy to come on as a nuclear innovation associate in November of 2017 at Clean Air Task Force. We are focused on helping create the sort of, we're focused on the role of clean, firm energy in our future decarbonization plans. We totally we're totally very supportive of, renewables. I have solar panels on my roof. I'm looking at them out through my window right now in my house here in Charlotte, North Carolina. Thank you, federal government and Duke Energy, for the subsidies. But we also see the need for creating the framework for the sort of multiple shots on goal optionality. I don't think they use it anymore, but I'm showing my age, the sort of food pyramid of energy, everything for what it needs to be and in its right role and the proper amount of servings, and that can be the most economic, practical, and timely approach to achieving these goals that, most people agree are extremely important.
Yeah, shout out to Ashley for spinning up that effort. She did a phenomenal job when she was at Clean Air Task Force. Nuclear Innovation Alliance, I guess, is the name of the subset that did it. And now she's over at NRIC. Is that right? We've still been trying to get her on I've been trying to hunt her down for 3 years, trying to get her on the show. Maybe we can put enough pressure on her to come on.
It took 3 years to get me, right?
That's also true. That's also true.
I was privileged and pleasured to work with Dr. Ashley Finan for a year or so or longer. But then in October of 2018, I believe it was. I'm sorry, with the pandemic, it makes all my years blend together. October of 2018, Ashley officially moved over to officially stand up the Nuclear Innovation Alliance, which began as a part of CATF and is, we like to consider, a sister organization of ours that has a different and more targeted focus rather than the larger overarching, sort of clean air, clean energy focus that Clean Air Task Force has. So the Nuclear Innovation Alliance, I apologize if you're hearing a dog in the background. He's rolling on the ground.
A cute little bulldog. Is that a cute little bulldog?
Yeah, a cute little pit bull.
Sorry.
No, it's okay. Sorry. Rolling around on the ground. Sorry. So the Nuclear Innovation Alliance is, really focused on advanced reactors and the opportunities for deploying advanced reactors and policy associated with advanced reactors, which is just a subset of, sort of what Clean Air Task Force is focused on. And so NIA spun off its own activities, stood up on its own, is its own, independent organization now, as opposed to Clean Air,
Okay.
Association from Clean Air Task Force. And then Ashley left to go be the first executive director at NRIC. And NIA has recently, September of 2020, hired their new executive director, Judy Greenwald, who's fantastic. And the NIA is up and running, and with Judy Greenwald, and making great strides currently right now. But that's kind of, CATF likes to work in, not alone, we like to work in an ecosystem. We'll work alone, and we'll run that, we'll carry that spear, and we'll run that flag if we have to. You get more, bees with honey than with vinegar. And, it's you can give along to get along. I don't know how many more, I can throw out here, but, it takes a village. There you go. It's all about the team and the groups. And, we're, a sort of more left-leaning organizations, and collaborating with groups that might be more center or right-leaning and having similar sort of perspectives or recommendations can be very powerful, especially if you're, groups that are respected and, well considered and thoughtful, and have been invited to participate in the conversation.
It's funny you mention that, because that is one thing that I do find, there's a lot of things special about the nuclear industry, but one thing that I find extra special, and maybe this is just because I'm in DC, and I get to see the center groups, the center right groups, and the center left groups that are the various groups, that support nuclear energy, or focus on it and have it as part of their core discipline to understand it, how well everyone gets along. And just like, at like the happy hours, just being able to have like good debate, like never anything personal, great debates about policy broadly, not just nuclear. But it just seems to me that like the people who are in nuclear policy are, they come from all sides of the spectrum, but are just like so intelligent and educated and able to create these amazing arguments and really understand like the fine nuances of, of not just nuclear, but broader energy and climate goals. I don't know. I love it. I personally love this community.
I love my job. I very much enjoy, this is the best job I've ever had in my life. I very much enjoy, and I used to be a licensed pyrotechnician. So
I think we just found your quote that I'm going to put on my LinkedIn social post.
Best job of my life. Best job that I ever had in my life. But I used to be a licensed pyrotechnician. The community is great, if small, and sometimes slightly siloed in a lot of ways. So to me, it's exactly kind of what you talked about. Like there's a lot opportunity now and in recent years for bringing more people into the tent, for being inclusive, for recognizing the value of others' ideas and different perspectives that might be, very different from my experiences, supporting existing nuclear power plants, and so those experiences and perspectives aren't invalid because they're different, or I have a set of facts that, and data that support, what I say, because I'm sure, like I said, nuclear engineering is hard, and there's lots of different ways to prove a point and skin an apple and do all these different, or skin an apples. Yeah. And
now we have mixed metaphors.
Yeah, right. I
think you can skin an apple though.
Yeah,
right?
I guess that would be okay. I guess that would be okay. Yeah. So the goal here, and in a lot of ways, the goal for sort of the nuclear sort of advocacy, which in a lot of ways we don't even see ourselves as a part of. In a lot of ways, we're clean energy advocates. We're clean, firm energy advocates.
Yeah, it just happens to be those things have a huge amount of overlap.
Yeah, nuclear just happens to be a part of that, And but I mean, if something really cheap and super better came out tomorrow, and we might change our tune, but that's not the way it is right now. And so we need this optionality for all of these different options. And advanced nuclear has this great opportunity potentially. And it was about for many years getting into the tent, being seen as clean energy, having the right dialogues so that it's not just, I hate to say it, in a lot of ways, the nuclear bros, as sometimes people tend to call that very, passionate, but sometimes misinformed or, difficult to wrangle sort of group of nuclear advocates. That it's not just about who can scream louder or whose facts are best or whose data is best. There's a lot more that goes into it.
It's about communication and coalition building. And I think, yeah, that's what your organization has also done a great job at. Tell me more, though, about the types of stuff you work on a day-to-day. What are you digging into when you research or you write? I mean, I saw you've been quoted in a few international articles lately. What is it that you're doing in support of the organization very specifically?
Sure. So right now, I'm I'm sure we announced it recently, but I'm very happy to announce or say that, we've recently expanded our team. Beginning of this year, we hired Carlos Liebner, who's a former, Framatome and Westinghouse director, executive, and he has joined as our director of global nuclear strategy. He's currently based in Rio de Janeiro, Brazil, and his focus is more on the sort of global nuclear opportunities and overall theory of change for seeing, nuclear potential reached on a global scale. My personal purview tends to be more focused on technology innovation and domestic US federal policy. So we're spending, of course, I spend a lot of my time interfacing with federal staff, federal staffers, congressional staffers, and federal employees and members of the administration. We have spent numerous years advocating for the restart of the Department of Energy's low dose radiation research program. So we convened a group of experts in September 2019 in DC. This group of experts coming from multiple different universities and radiation epidemiology or radiation biology backgrounds associated with low dose radiation research or low dose radiation understanding. And this group came together and formed some recommendations for what a new federal low dose radiation research program would look like and how it should be strategized and led. And so we've taken that and we continue to work with those experts and thoughtful and understanding staff members and members of the administration to see that program fully started up and appropriately funded. We've also recently closed out or ended over a year-long process that where we collaborated with the Edison Electric Institute, NEI, several other NGO sort of groups like Third Way and ClearPath, and numerous sort of Edison Electric Institute members in order to come up with what we're calling, or what we have called and released as the Carbon-Free Technology Initiative, which is a set of policy recommendations for certain different technology groups to help utilities and companies, customers like EEI's members be able to purchase and buy technologies that they need by 2035 or by 2030 or whatever to meet these decarbonization goals that they've met.
So this is understanding different technologies that would fit into clean energy goals and getting that information to a report form that's then given to, let's say, utilities, so they know, so they can educate their staff on what to purchase 5-10 years out.
So it's really more even before that. These are federal policy recommendations that are we're going to begin, that we are circulating, we will continue to circulate among policymakers, that will create the environments for the development of these sort of technologies. So there's nuclear energy and advanced nuclear recommendations in there, and these sort of things are like increased funding for and increase in sustained funding for the advanced reactor demonstration program, funding the versatile test reactor, in addition to certain newer programs or new to the discussion programs that would additionally help support the deployment of nuclear technologies. And there's 5 or 6 different technology bins that each have their individual recommendations. I believe they're all out there on carbonfreetech.org is the name of, is where we've released all the information. So we spent over a year doing that, thanks and kudos to the Edison Electric Institute for kind of convening the group and helping us and allowing us to help facilitate. I facilitated or helped facilitate the nuclear fission and fusion discussions.
Very cool. Yeah. And so, we only have so much time together on this podcast. Obviously, you and I will continue these conversations ad infinitum, but maybe just tell us a little bit about what you see in the advanced nuclear technology landscape looking down the road. Get people excited. I want you to paint an optimistic picture, 5, 10, 15 years out of where this industry is going.
So I really hope, it doesn't have to be that far out, 10, 15, but I like to be optimistic and shorter term than that. And I will, of course, also express my particular bias.
This is your show.
Yeah, right. Time frame, if I have to look at things on the horizon, first of all, I'm super excited by our first non-light water reactor license application before the NRC right now. So Oklo, and again, expressing my bias, I went to college with one of the founders of that company, Dr. Jacob DeWitt, who, is an okay dude.
We like him. We really like Jacob. Actually, that's another one I've got to get on the show. Once again, great guy. Have had amazing conversations. Love the innovation that he's bringing to the industry. Can't get him on the show yet, but maybe a little bit of pressure will get him on.
He asks me stuff. He texts me stuff randomly, and then I text him back answers. And then like 4 months later, he texts me and he's like, "I am so bad at this." So yeah, I mean, they're so busy. The only time I ever really get to see them anymore or talk to them anymore was when we would cross paths in DC, so it's been over a year since I've been on a plane to DC, which is crazy. That's
non-light water reactor. What other?
First non-light water reactor. They have their application before the NRC right now. They're hoping to deploy with a build, own, operate model, which is pretty unique within the community. I think at the latest by 2025, but they're trying to target deployment earlier than that, 2024, 2023.
That'd be amazing.
And I mean, we're talking about a project that I believe was submitted and docketed in March of last year. Again, March 2020. Again, I'm sorry, I get my pandemic blends all my time together. And that was projected for a 36-month ish review time frame. So this could happen. This could be probable, and they are also have talked about beginning construction while their review is still happening. So I'm optimistic to see a Oklo Aurora micro reactor at a site, the Idaho National Laboratory, by 2025 or before, hopefully, fingers crossed. I'll cross both.
Yeah, let's do it.
I'm excited by the Ultra Safe Nuclear Corporation demonstration of their microreactor in Canada. I believe the date is 2024 at the Chalk River
Good
site.
technology, horrible name, but go on. Yep.
Yeah, right. And then they are also pursuing a potential deployment at the University of Illinois Urbana-Champaign campus as a research test reactor. So, I'm also very encouraged by that. The Advanced Reactor Demonstration Program calls for the two main demonstrations, the Natrium TerraPower General Electric Hitachi demonstration and the X Energy XE100 demonstration.
And the X Energy, that's Kim Gafarian's brainchild, and TerraPower is associated with Bill Gates, right?
Yep, correct. And so that we hope to see those two projects by 2027, along with associated, which I, as a former fuel guy, think is extremely important, along with associated commercial fuel fabrication facilities, because Natrium is pursuing a metallic fuel, which we don't have any commercial scale capabilities in the United States right now to build the type of metallic fuel that they need. And X Energy is pursuing TRISO fuel, which we have very limited commercial capabilities to build in the United States right now. We discussed and we brought up the National Reactor Innovation Center as well, which I believe is mandated to demonstrate an advanced reactor by 2025.
Amazing.
And I believe their stretch goal and their stretch commitment that you can read on their website, maybe it's changed, I don't, when the website first launched, I saw it, was to demonstrate 2 reactors by 2025.
Love it.
So, that's the potential for, in North America and Canada, the demonstration of 5 different individual types of advanced reactor technologies by, the 2025 to 2027 timeframe.
Any advanced light water reactors being built, I feel like that could potentially even have a shorter path to market, given you don't have to really change the fuel or the coolant type. Anything we see there?
Yeah, I see lots of opportunity there as well. Holtec's SM160 or SMR 160. I apologize, Holtec, for mischaracterizing the exact lettering of your reactor's name. But that reactor design won a ARDP risk reduction reward. The risk award, excuse me, it's not a reward, it's an award, not a reward. The award for risk reduction targets a different sort of time frame. It's a beyond the 2027 time frame. So, but Holtec is in engagement and pre-engagement with the NRC on that design, and has been for several years. NewScale has received their design certification for a first 50 megawatt product. They are planning on pursuing a standard design application for a subsequent larger electricity producing product, and their time frame for the carbon-free power project with their customer UAMPS is 2029 right now. So, a little bit staggered, or a little bit later perhaps, but I don't think that should say anything that we couldn't see something happen very, very quickly, in the next 5-9 years, whatever it is. Lots of opportunities for advanced light water reactors as well. I've heard NewScale in the public saying that they can deploy with a different customer, or with the right customer, with the right sort of framework in 2027 as well, if they found the person with the right opportunity. And the carbon-free power project is staged to 2029 the way it is, to support, according to UAMPS and NewScale, to support the UAMPS subscription base and customers. So lots of opportunities.
Anything from GE? I know they had an interesting reactor design as well.
So I as a former GE employee, I love that BWRX 300. I think that thing is beautiful. Yeah. I believe most of the nearest term opportunities for the BWR X300 are not domestic US right now. I think there's, I apologize to Western Europe for, getting it wrong, but I'm sure I'm going to get it wrong because there is a lot of activity going on in Western Europe in relation to, consideration of nuclear technology or deployment of advanced nuclear technology. And I know there's been agreements and discussion in Estonia and Bulgaria, and the BWR X300 has come up in certain of these nations in those discussions. So yeah, lots of opportunities. I know there's also been for many years discussion of an advanced light water SMR at the TVA Clinch River site. So there's an opportunity there. Not sure, how much TVA wants to pursue that. There's also Kairos is pursuing demonstration at some, the Oak Ridge technology parks in that sort of region. So there's a lot going on, and that, an advanced SMR may not, or an advanced light water reactor, a light water reactor SMR may not happen for the Clinch River site, but that has always been something that's been discussed as well.
Brett, as we wrap up today, tell me why you love nuclear. Tell me why it's important. This is you personally, not your organizations. Just why is this? I mean, I know you feel this way. Why is nuclear an important part of the future?
Well, I think all you got to do is look at where we're at right now. And more than half of the US's clean energy comes from nuclear energy right now. And when you look at global primary energy usage, because electricity, I shouldn't have said energy usage. I should have said electricity usage in the past when I was talking about the clean energy and nuclear being 50% of it. It's clean electricity. Nuclear is 50% of it. But when you talk about primary energy usage, the problem just becomes so much more daunting. On a global scale, 80% of primary energy is still devoted to fossil fuels. And while there's a lot of talk about increased electrification and the opportunities for renewables and batteries and everything, when I look at the United States, I don't want to be asking the questions of how do I achieve these goals and how do I decarbonize the harder to decarbonize sectors of the rest of our economy besides electricity without things like the existing nuclear fleet that's providing 50% of our clean electricity, or the optionalities offered by, different forms of clean, firm energy, nuclear energy included in them as one of the, hopefully nearer term or prominent forms of clean, firm energy. So yeah, I embrace and have centered my career around nuclear technology because, number one, I like to be challenged, and this was a challenge. This has been and always has been a challenging and rewarding career, even when I was, doing computations versus the rewarding stuff I do now. And in addition to that, I don't want to be doing something that I've always wanted to do, something where I feel like I'm giving back. And if I can help facilitate or help support, the US's largest source of clean electricity, I feel like I'm giving back.
Brett Rampal, thank you so much for today's conversation, for sharing your insights over the years, for educating me in my early days, and for your contributions to the community. We all appreciate it. Thank you again.
It's been my absolute pleasure, and thank you so much for having me.
And initiate at least a new approach to the many difficult problems that must be solved in both private and public conversation if the world is to shake off the inertia imposed by fear and is to make positive progress toward peace.